Hi. Okay, this is the third video about solving equations by factoring, and in this one we're actually going to solve equations by factoring. The first two were just about how to factor. So now we'll see why that's useful for solving equations. The key idea here is something called the zero product property. It's a fancy name, but all it means is that if you multiply two numbers together and you get 0, then at least one of those numbers has to be 0. This is just interesting because it's not true about any other number. If you multiply two numbers together and get 5, it might be 5 and 1, or it could be 2.5 and 2, it could be negative 2.5 or 2, and there's infinitely many options for both of the factors. But if you multiply two things together and get 0, then that's a special property of 0. One of them has to actually be 0. So here's the idea. Imagine we had this equation here. So this is a quadratic equation that's already been factored. If we need to solve that, what we see here is we've got something times something else equals 0. So here's the idea. What we're going to take, we've got two things that have a product of 0, so at least one of them must be 0. So there's two options here. Either x plus 5 equals 0, or else 3x minus 2 equals 0. Okay. So that's the big key idea right there. Once you've got them factored, then if it has to be equal to 0, otherwise nothing works. But if it's factored and equal to 0, then either one of the factors has to be 0. So now we just have two little linear equations. So we'll solve them. Subtract 5 from both sides here. Then we have x equals negative 5. And in this case, I'll add 2 to both sides. And I have 3x equals 2, and I'll divide by 3. And we have x equals 2/3. So there's two solutions to this quadratic equation. Many quadratic equations have two solutions. That's totally normal. It's sort of what you expect when you solve a quadratic, is to get two solutions. So x can be 5, and x can be negative 2/3. Okay, so that's the big idea. So, a few steps for people who like lists. To solve a quadratic equation by factoring, the first thing you do is you have to rearrange it to equal 0. Because we need to apply the zero product property. Otherwise, factoring essentially tells you almost nothing. So if the equation isn't already equal to 0 on one side, then you have to get everything over onto the other side of the equation so it does equal 0. Step 2 is factor. And step 3 is set the factors equal to 0 and solve. So all that means, that's this step here. So if you've got, it's factored here, it's equal to 0 and it's factored. So you take one factor, you say, well, that could be 0, or else the other factor could be 0. And then you solve those little linear equations. This one here is as hard as it gets for solving little linear equations like that. Okay, so I'll do two examples here. I'm not going to do the actual factoring. I might do that relatively quickly, because you've seen a couple other videos about how to do the factoring. So feel free to pause right before I factor if you want to sort of stop and figure it out yourself. Okay. There. So the first one here, we've got x squared plus 7x plus 12 equals 0. So if I check my list of steps here, the first one is rearrange it to equal 0, and that's already done. So we don't have to do that. Second thing, factor. So factor this here. That's going to be, I need things that add to 7 and multiply to 12 times 1. It's going to be x plus 3 times x plus 4. Okay, and you may have factored that a different way, but you should get the same answer. So, at this point, we have two options. Either x plus 3 equals 0, or x plus 4 equals 0. I like to kind of put a line there to really separate them, so that they're two completely different options at this point. So if x plus 3 equals 0, subtract 3 from both sides, and we get x equals negative 3. Or with the other option, we've got x plus 4 equals 0, subtract 4, and we have x equals negative 4. So those are my two solutions to that equation. Now the question asked me to check by substituting back into the equation. So that's one way to check. You could also check, if I didn't specify a way that I wanted you to check, you could check by solving this graphically on your calculator. That would be a pretty quick method. So I'll check that x equals negative 3. And that's going to give us, so we'll substitute it on the right hand side. We have negative 3 squared plus 7 times negative 3 plus 12. And that's equal to 9 plus negative 21 plus 12. And that is equal, that's 12, so this is 0, 0. And this is right because that's what the equation said it was supposed to be equal to. Okay, same thing with x equals negative 4. Got negative 4 squared plus 7 times negative 4 plus 12. So that's 16 minus 28 plus 12. And that's also 0. So it won't always have to be equal to 0. It just has to be equal to whatever the original equation said. Okay, cool. Okay, so here's a slightly more difficult one over here. We have to solve this equation. 2x squared plus 3 equals 5x plus 1. So back to my handy list of steps. The first step is to rearrange it to equal 0, because otherwise factoring doesn't mean anything. So I'll do that. I'll subtract 5x and subtract 1 from both sides. Okay. And then over here I get 2x squared minus 5x plus 2 equals 0. Okay, so I've rearranged it to equal 0. Now I need to factor this. So I'll just use a trial and error. I know I need 2x and x to get that. And I know both numbers here are going to be negative because I need it to multiply to negative. These two numbers are going to multiply to positive 2. But they have to, when I simplify and find my x term, I have a negative 5x. So they're both going to be negative. And it's got to be 2 and 1. If I kind of imagine where they're going to go and what it would simplify to, I can see that the 2 is going to go there and the 1 goes there. That might take you more than one try, and it's totally fine if it does. So to check, we got 2x squared minus 4x minus another x, so that's the minus 5x plus 2. Okay, so we rearranged it to equal 0, factor, we've done that, and then set the factors equal to 0 and solve. So two options here. We might have 2x minus 1 equals 0, or x minus 2 equals 0. In fact, it's not necessarily one or the other. Both of them are solutions. So we just have two solutions. So in this case, we've got 2x minus 1 plus 1 equals 0 plus 1. 2x equals 1. Divide both sides by 2, and we get x equals a half. And here we've got x minus 2 equals 0. I'll add 2 to both sides. I have x equals 2. Okay, so I want to check these. Check x equals a half first. Because I've got x's on both sides of the equation. We should always check them right in the given equation, just in case you made a mistake on the first line or something. So I'll substitute right back into this equation. But I've got x's on both sides, so I'm going to substitute at the same time. But I have to be careful when I'm checking that I don't say that this with my a half is equal to that necessarily, because it might not be. That's the whole point of checking it, is to see if it is. So when I do that, I'm just going to put an equal sign with a question mark over, just to sort of indicate that I'm checking. So we have 2 times a half squared plus 3. And the question is that equal to 5 times a half plus 1? Okay, this is a fourth times 2 is a half. So this is 3 1/2. And then this is 5 times a half is 2 1/2 plus 1 is 3 1/2. And these are in fact equal, so that's perfect. That's what we want. It doesn't matter what they're equal to as long as they're equal to each other. Okay, and then I'll check x equals 2. So 2 times, substitute x equals 2 squared plus 3. And is that equal to 5 times 2 plus 1? So 2 squared is 4, times 2 is 8, plus 3 is 11. And here I have 5 times 2 is 10, plus 1 is 11. So these are also equal. So that means that is also a solution. So notice that here it came out to 3 1/2 on both sides, there it came out to 11. That doesn't matter as long as the equation is true. The two things are equal to each other. Alright, thanks.